So I will be talking briefly about our presentation for today. It is enhancing decision making. In here, we integrate spherical fuzzy AHP with Opara method. So the motivation came from a place high up in the mountains in India that is called Ladakh. And most of us want to visit this place. So Ladakh has a mega solar power project. It wants to develop it. In India, we want to have 500 gigawatts of renewable energy by 2030. And in Ladakh, they can connect about 10 gigawatts directly. So the factors that are available on the surface as of today is environmental conditions, economic situations, cost, etc., technology opportunities, and the site characteristics. According to the government and the Ladakh region, they are planning for solar development at 4 different locations, and they want to contribute to the sustainable future energy. This is good, so we have no issues. We understand that choosing one location, sorry, please, I will just put it up. Choosing one location based on several criteria, one of the techniques that can be used is an MCDM approach or a method. Since this problem includes both subjective and objective criteria, the selection of the appropriate method becomes an important requirement. We did look at the various initial techniques that we are through with or thorough with, like AHP and TOPSIS. They rely on pairwise comparisons, ratio analysis. But the reason is they would not be able to provide us more information in real world data. There would be uncertainty and ambiguity. For this reason, we have taken up spherical fuzzy sets which consider a little bit of uncertainty or more of uncertainty and hesitancy of the respondent. The ranking of the alternatives, we are trying to work with the Opara method. Hence, this is an integration between the two methods, spherical fuzzy, its flexibility, performance can be enhanced by using Opara method. A little brief about the spherical fuzzy sets and Opara method and giving, because this was very interesting. So we had Professor Tahir Rahman in this ISAHP2024. So that was another motive to be in this session number 9. So here in spherical fuzzy sets, what happens is, because we are looking at the IFS, we are looking at the PFS, and we are looking at the neutrophilic sets, it allows for the robustness by capturing uncertain. So if you have 3 of them, and then which one does it take? So that gives a little bit of robustness on capturing the uncertain or an imprecise judgment. These sets do not independently handle each parameter, thereby limiting the flexibility. We also know that Rahman in 2009 developed spherical fuzzy sets, and he said that it can overcome by allowing adjustments for membership, non-membership, and hesitancy. It can provide a more adaptable tool. So we set in for the spherical fuzzy AHP and the spherical fuzzy TOPSIS. So we worked in spherical fuzzy AHP. Now we have certain equations that have been taken up and we have looked into them. They are given in our appendix. The paper is about 12 pages, and because of paucity of time, we cannot be explaining them all here, but yes, we can do it when it is required. In the Opara method, objective pairwise adjusted ratio analysis. It is another MCDM approach. It involves identifying alternatives. It evaluates alternatives with respect to the selection criteria. It can use two adjusting parameters to modify the ratios based on the range and linearity of the criteria. And finally, it calculates the ranks of the alternatives. So what we have done to our problem or to our motivation, so we have now integrated it and put it in spherical fuzzy AHP, some of the steps, and then the rest of the steps where we did the ranking of alternatives as per the OPARA method. So this is the AHP method, and this is our OPARA method. So in case we need to go, we will go through them in the question and answers. We would like to work there. So we converted them into the linguistic. So it was that you will have an absolutely more important, very high importance, and relatively very low importance, and absolutely low, giving the score index 1, 2, 3, 4, 5, 6, 7, 8, and 9. So between them, we were able to manage and look into it for our power plant. So what we did, we have not gone beyond the second step, which we intend to do now that we have got data, and we would be traveling to the places in Ladakh to collect more data, and we will be having it. So for the first part, where we want to do a site selection, the priority, whether it is Pang, whether it is Kargil, whether it is Chengdo, and whether it is Leh. So we will be looking at these four based on the four environmental, four space. So this is the location-based requirement. So these are the four locations. These are the criterion for them, and we would like to select them working on the SFAHP OPARA method. So based on the linguistics and based on these four criterion, C1, C2, C3, and C4, we were able to get the values based on the linguistic factors that we were able to collect through the set of initial group decision makers. And this has been presented here in the small format here. Now, to look at the alternatives for them. So for example, C1, C2, C3, and C4, the environmental conditions possibly could be the annual solar radiance that is measured like this. The economic situation would be the cost of installation, then the carrying capacity from various locations, to that the infrastructure, carrying of infrastructure to various locations. Then what are the available solar technologies? Yesterday we were looking at blockchain in one of the presentation, and we found that apart from Hyperloop, there is another method which has been taken up in a big way. So we would be looking for, same way we would be looking at the various advanced solar technologies, and finally, the suitability of the land, the rainfall, the what is called as the tremors, etc. So we will be looking at all of them in the second form. But here, when we did check on the initial one, and we were able to get through the FUZZY-AHP OPARA, the A2. Excuse me, Ajay is there? He can take up from here, please.
Yes, ma'am. Hello, ma'am. So for the four locations that we had selected, we ran our proposed, ma'am. Yes, we ran our proposed SFHP OPARA, and we got the following ranks. And we also did a comparison with the AHP, SFAHP, and OPARA. And the comparison table is provided here. We can see the ranking has a significant shift. And from this, our ranking is to locate the solar plants at the second location. And could you go to the next slide? So to conclude, we have presented an integration of spherical AHP and OPARA, where the criteria weighting is done through the spherical AHP and the alternative ranking through the OPARA method. So by this integration, we are capturing the uncertainty in the respondent's judgment with the spherical AHP, and we are eliminating the normalization of the alternative values with respect to criteria with the OPARA method. And also for the taken example, we are able to find the optimal location, preferable location with our method. This method also has multiple uses in public policy and resource management, strategic planning, etc. in the real world scenarios. Can you move ahead?
Yeah. So you mentioned also.
Yeah. So to just highlight the approach in reliability. So we have the integration of the spherical AHP and OPARA is suitable for complex scenarios where the judgments of the respondents could be captured in a holistic way. And the reliability also with the comparison, we could say that the dependability on this method for appropriate results is high. Also, the application is broad and it's suitable for many real life scenarios. So that ends the presentation.
Thank you very much. Thank you very much. You even left more time for question and answers. Any questions from the floor? Thank you. Thank you very much. Get well soon, Saroj. I think you had some cold. Any questions from the audience?
I have a question, Birsen.
Go ahead, Claudia.
Thank you. I would like to ask if the comparison between different methods is doing over ordinal or cardinal ranking, because what I saw in your presentation, it seems to be ordinal ranking. I am wrong, or please let me know.
Yeah.
Could we go to the slide, ma'am? Can you please share the slide, ma'am? Yeah.
So it's, I'm sorry, I didn't hear you. It's ordinal ranking?
Ma'am, it is, sir. It is.
Okay, then you have to be aware that if you compare ordinal rankings, you may have some issues because sometimes if you have a first alternatives close to the second, it's very different to have the first very far from the second. Sometimes inverse order represent much better a solution than the first and second order. That's happened when you have ordinal rankings.
Okay, sir. Okay. Well, thank you for the comment, sir. We'll definitely note it for the future works. Thank you, sir.
Yeah, because we now have to get on to the different forms here in the second level, and definitely we will take it there, please. Thank you very much.
Any other question from the audience? I don't see any in the chat. Actually, you can use any methodology you like to, but you can really solve these. I don't know if there are some dependencies above the criteria. For example, I just saw cost, but I think you need to go in terms of structuring model. I think there are certain things needs to be addressed. So just installation cost is not sufficient. So you have some other criteria, and you can use even if there are some uncertainty about you can still use AHP because as I say, AMP, AHP, it is already fuzzy. You can still use it. And we don't know if the results are different. We don't know which result is the correct one.
Okay.
So, but
Some
it's okay.
always say that.
Yeah.
Because that
Yeah.
HP is already fuzzy.
Yeah, it's already fuzzy. And another thing, I think you shouldn't that much concern about the consistency. Just concentrate solving the problem.
Okay.
Consistency will be handled by itself. If you really, if it is too much inconsistency, just concentrate it and interact with your decision makers. Quite probably this will go down. But my suggestion is first, I think you should look at the structuring of the problem, because I am not quite sure if really what is represented reality what you wanted to solve.
Ma'am, point taken. Thank you.
Any other questions, comments from the audience? Thank you very much. We still have 2 more minutes, so we can use. Yeah, okay.
Yes, we can use.
Yeah, we can use it as a break time and socialize. We didn't